All right, if you were absent or you need to get caught up, here is what we did in class on December 3rd for our 5.1b lesson. The first thing we did was we started off with our warm-up. Here we wanted to find the length of the segment KN. So I'm going to go over here and make sure I know exactly where that is, make it all bright so I don't forget after I solve for x I'm not done yet. Now, when we take a look at our picture here, I see here that this segment, KB, I see a 90-degree angle, so it's perpendicular, and I see congruent markings telling me I have a perpendicular bisector. More specifically, because we have a perpendicular bisector that comes out, the perpendicular bisector comes out of the vertex. Therefore, these little dots meaning therefore, we have an isosceles triangle. Okay, so this is now going to bring us to the fact that we can now say that segment KH is congruent to segment KN, also giving us the measurements are equal. So KH is equal to KN. So we're going to take this information and we're going to set these two equal to each other. So over here, I will take 3x and set it equal to x plus 10. At this point, you're going to pause and you're going to solve for x on your own and then resume to see if you solved correctly. In 2 simple steps, we find out that x is 5. Now again, highlighted bright is the fact that I wanted to find the length of segment KN. So we look over there and we see that KN is x plus 10. So I'm going to substitute in 5 for x. Sorry, a little messy there. So giving us that the final length of KN is going to be 15. Okay, this is using our perpendicular bisector theorem. Next in the notes, Ms. Biggs helped you guys set up to kind of figure out what was going on here with our angle bisector, knowing that we have angle 1 and angle 2 are going to be congruent, therefore their measurements are equal. So all we do is we set these two equal to each other. And in this case, luckily, we are only looking for x, so once we solve, we're done. So here we're going to have 5x plus 8 set equal to that 8x minus 16. So go ahead and pause the video, solve for x, and then resume to get the final answer. So after we subtract the 5x from both sides, 8 is going to be equal to 3x minus 16. Add that 16. I'm going to make it a little bit smaller. I'm going to run out of room. We get 3x is equal to 24. So after dividing, x will be equal to 8, and we're done. That's all we wanted to find. Next, after the original video that Ms. Biggs made, she talked about the angle bisector theorem and the converse of it and what is going on. We were instructed that we need to do number 3 and number 4. She did the first number 4, which should be number 2, on the video, and then so now we're going to take a look at number 3. What I want you guys to know is I have already highlighted what I need to find, because this is where we're going to get thrown off, and we're going to want to say, well, okay, this is the converse. Here I've got congruent segments, and I also have my 90-degree angles here. So I have perpendicular sides, so that's going to tell me that I have congruent angles according to your angle bisector theorem. So students are going to want to say, okay, well, our answer is 37 degrees, but that is not correct, because look at what's highlighted. I want the entire thing, measurement of angle JKM. So before we do that, we want to make sure that we have plenty of notes to help us remember why we did the work we did. So going back, we saw here that JL was equal to LM, and we saw here that we had perpendicular sides. So we're just going to shorten and say perpendicular sides. So this will then tell us that the measurement of angle JKL is going to be equal to the measurement of angle LKM. So JKL and LKM. This then brings us to our angle addition postulate. So because I understand that each one of these is going to be 37, but if we want to go ahead and review our angle addition postulate, we're looking at trying to find the measurement of angle JKM. Well, the measurement of angle JKM is equal to angle JKL and it added to angle LKM. Part plus part equals the whole. So here we'll write it's equal to the measurement of angle JKL plus the measurement of angle LKM. Simply put, our measurement of angle JKL, we're going to, or JKM, sorry, we're going to go ahead and substitute in 37 plus 37, giving us a final answer of 74 degrees. So always pay attention to what are they looking for. They want the part or they want the whole. We've seen that with median as well, with our quizzes activities. Now number 4, again, Ms. Biggs helps you guys kind of set up that we've got a ray bisecting an angle. Therefore, our side, or sorry, and also we have the 90-degree angles. Therefore, we're going to have congruent segments. So NS is going to be equal to SP. So what we can do is now set these two equal to each other. I've already highlighted what I need to find, so I remind myself I need to substitute in the end. So MS over here, 3x plus 5, will be equal to SP, 6x minus 7. Pause the video and solve for x, and then we'll substitute in. So here, after you've paused it, we're going to subtract that 3x from each side. We're going to have 5 equals 3x minus 7. We're adding that 7 to give us 3x is equal to 12. Finally, dividing, x is going to be 4. Now remembering that we're not done, we need to substitute in. So here, SP is equal to 6x minus 7. Remove x, and we're going to put in 4. And whether you want to do baby steps or all at one time, here I'm just going to do the baby steps. 6 times 4 gives me 24 minus the 7. And then once we subtract that, SP is going to equal 17. All right, now we're going to go back to the first page of the entire chapter and complete our last section, which is going to be right here. In the video, in the notes, we talked about how the point of concurrency with with our angle bisector is an in-center. So here, going very quickly, this is going to be a point where 3 angle bisectors, there we go, spell it right, bisectors intersect. And in this case, this in-center is always going to be inside the triangle. So when we draw our 3 angle bisectors, we're just going to have to play the guessing game. We're not measuring. So we'll just go to the top angle, we'll just go down somewhere. But how we're going to tell the reader that this is supposed to be an angle bisector is we're going to make our congruent markings. Then I'm going to go over here to the left angle, or the left vertex, and again, I just have to guess. Just draw a line, and then we'll mark 2 congruent marks here. When we do our third angle bisector, our goal, because we have to have all 3 intersect, our goal is basically just get through this intersection here. So we'll go through, and then mark it with 3 congruent marks, giving us that intersection right here, and this is going to be our in-center. Now the last 2 bullet points deal with your in-center, the theorem, and we're going to kind of quickly go through this because I know academic we're not focusing too hard on this one, but this in-center right here is also going to be the center of a circle that is inscribed. Again, this was discussed in the lesson. It's inscribed in the circle. So inscribed is just going to mean drawn inside. So what we're going to do here is we're going to just kind of try to draw a circle the best we can. I know circles don't really come out the best free-handed, but our goal is to make sure that circle hits all 3 sides of that triangle. And what we're saying here is that if the in-center theorem is that point is going to be equidistant, that in-center will be equidistant, equal distance from the sides. Now when we looked at the triangle before with our circumscribed, circle around the triangles with circumcenter, we talked about this equidistant from the vertices, but now we're looking at equidistant from the sides. So as discussed in the video, if you go to that in-center and you go perpendicularly to each side of the triangle here, just like this, all three of these will be congruent. So then just to kind of take it a little step further, so, oh, not right there, sorry, should be over here. Take it one step further and we'll go ahead and label these G, I, and H. And we'll label our in-center as the point F. We'll add in a little statement underneath. And this is just telling us here that we have the length of FG right here. I drew that point off a little bit too, didn't I? There we go. I'm getting distracted. All right, so we have these points from the length of FG will be equal to the length of FI, in which will also be equal to the length of FH. And that concludes Chapter 5's notes.